All right, continuing on, we have 12.3 trig functions of general angles. All right, to get things started off, we're going to continue using sine, cosine, tangent, cosecant, secant, cotangent, as we talked about a couple days ago. And this chart here may look confusing. Please do not memorize this information, okay? All we're going to use is our same ratios as before. The important thing to keep in mind is as we're creating our angles, we're going to be given some sort of point. We always want to connect it back to the x-axis to create our triangles. And if you do that, then it's going to be the exact same as our very first day, 12.1. So example 1, it says, the terminal side of theta in standard position contains the point negative 6, 2. Find the exact value of the 6 trig functions of theta. So first step in these problems is we're going to want to construct our angle. So first things first, I'm going to draw my point, negative 6, 2. That's just an approximation. Something like that. And then what you're going to do is you're going to construct your angle. Okay? Like I said before, you always want to take your point wherever it is and connect it back to the x-axis. And that's how you create your triangle. And theta is going to be that acute angle next to the x-axis, which means the opposite side is my y value. The adjacent side is my x value in my point. And then you need to do Pythagoras theorem to find that third side. So if I take 2 squared and negative 6 squared, you're going to get 40, which means I should make that equal to x squared. So when I square root both sides, I'm actually going to get 2 square root 10. All right. And then as we go through to set up our ratios, we're going to do everything the exact same. So remember, I'm trying to make this a little better so I can write. So our sine ratio, remember the opposite side was our y value, which was 2, over the hypotenuse, which is 2 square root 10. After these cancel out, we have the square root of 10 on the bottom. So again, we have to rationalize just like we did before. We wind up with the square root of 10 over 10. Cosine, using our ratios just like we did in 12.1, your adjacent side. Now instead of being a positive length, x and y can mean position in terms of our graph. So in this case, our adjacent side is actually negative 6, and our hypotenuse is 2 square root 10. So if I rationalize at this point, we have negative 3 root 10 over 10. And then our tangent of theta, at those points, our opposite side is positive 2. Our adjacent side is negative 6, so the tangent value is negative 1/3. So you can see, just like we did before, the hardest part of the day is going to be that construction piece, and then our ratios are set up the exact same way as before. Okay, and then like we said, our reciprocal functions, all we have to do is flip-flop. So we wind up with the square root of 10. Our secant of theta, if I flip, is going to be negative root 10 over 3. And the cotangent of theta is going to be negative 3. Again, figure out where your point lies, connect it back to the origin. That's going to be your hypotenuse. I'll kind of highlight that as I'm saying. So figure out where your point is, connect it back to the origin. That's going to be the hypotenuse of the triangle. And then you always connect your triangle back to the x-axis. Okay? So your opposite side is the y value. Your adjacent side is the x value. All right? As we continue on, things might get a little trickier if it's on the axis, but we do everything the exact same. Okay? Don't let this be confusing. Again, this piece here is not something you need to memorize. All right, we're just constructing triangles like we did before. So now if I change this up and I have the point -2, 0. Well, keep in mind if I connect my triangle back to the x-axis, remember that's -2. I'm almost thinking like this situation. So I have a triangle that looks like this. -2 is the adjacent side. 0 is the opposite side. So there's no height to my triangle. And the question is, what's the distance from my point back to the origin? Well, that's 2. So this is probably the most confusing part, is constructing that triangle. Just remember your opposite side is that y value, whatever it is. Your adjacent side is that x value. So if we are on the y-axis, then your adjacent length would be 0. So go through. After we have our triangle set up our ratios. So we do opposite over hypotenuse. 0 over 2 is just 0. Cosine is adjacent over hypotenuse. -2 over 2 is -1. Tangent of theta based on this triangle, or based on this position rather, opposite over adjacent, 0 over -2 is 0. And then we do the same thing with our reciprocal functions. The reciprocal of 0 is undefined. The reciprocal of -1 is -1. Keep in mind it's reciprocal, not opposite. Okay. The reciprocal of 0 in the case of cotangent is also undefined. So you may think it's tricky when we're on an axis as far as our position goes, but just remember that opposite sides are y value, the adjacent side is that x value. And then things should fall into place as far as things go. Okay? The last thing we're going to look at today is using our angles, excuse me, and then figuring out the reference angle. Okay? Reference angles are just an acute angle that's formed by the terminal side and the x-axis. So if you think about those problems before, remember I said it's important to always connect your point back to the x-axis. And this is the reason why we're really going to focus on reference angles for the second portion. So as we're constructing reference angles, you can look at this chart, or we can just go right to our graphs. So if I were to construct the angle -110 degrees, I'm going to rotate clockwise -110 degrees. So the question is, with our reference angles, what's the angle between the terminal side and the x-axis? Well, this should be really easy. If I went 110 degrees clockwise, that means my reference angle must be 70 degrees. Okay. Radians should be just as easy. And actually, to be honest, reference angles are almost easier when we're working with radians. Notice this angle is positive, so I'm going to rotate counterclockwise. 1/4, 2/4, 3/4, 4/4, 5/4. So I'm down in quadrant 3. And the question again, sorry, before I switch colors there, that's 5π4. Now I'm looking for my reference angle, which is between the terminal side and my x-axis. Well, the question is, what's the angle measure there? Well, we know the angle measure is π4. Keep in mind, you guys, with your reference angles, they are always going to be acute, or less than 90 degrees, okay? So reference angles should always be less than 90 degrees, or if you're talking about radians, less than π12. They will always, always, always be acute. All right. Continuing on, the last part of the day is going to be completing our unit circle. And this might look really confusing, but it's actually quite easy, and it's based on our special right triangles. Okay? So what I'm going to do is I'm going to zoom in on our unit circle here. And the objective on this next portion is to fill in the coordinates all the way around based on our special right triangles. There's some key points we want to fill in first. And since this is a unit circle, we know the radius is 1. So we have 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Those are kind of our home points, the easiest ones to figure out as far as things go. When I move over to our special right triangles, if you notice, the very first thing we're going to do is we're going to focus on our 45, 90 triangle. Okay? So I'm going to kind of sketch that in here. Keep in mind the radius is 1. So when I go over to my special right triangle, oops. Sorry, I should clarify before we're going on. We're trying to figure out the coordinates at that point. So I'm going to use my special right triangle. If you notice, we want these to correspond. Right now, this value, square root of 2, does not work. I want it to be 1. So how can I make it be 1? Well, I divide everything by the square root of 2. Because now the square root of 2 over 2 is just 1. We've now created a similar triangle with very similar lengths, which is going to help me figure out the coordinates at this point. Well, if you notice, my x coordinate is 1 over square root of 2, which if I rationalize is square root of 2 over 2. The height of this triangle is 1 divided by the square root of 2, which is the square root of 2 over 2. Okay? So the coordinates at 45 degrees on my unit circle are square root of 2 over 2, square root of 2 over 2. Please keep in mind, you guys, as you're going through these problems, the cosine is always going to be, and if you notice, cosine is adjacent over hypotenuse, is always going to correspond to your x coordinate. Sine is always your opposite over hypotenuse. And if you notice, that always corresponds to your y coordinate. So as you're going through these, that's a super important thing to keep in mind, is your coordinates on the unit circle are always based on the sine and cosine of our special right triangles. At this point, once we know one of the angles, it's actually really easy to fill in the rest of them. Because if I go over to quadrant 2, I know my coordinate pair is going to be the same. It's just my x value is negative. If I go to quadrant 3, I know both my x and y values are both negative. If I go to quadrant 4, I know the x values are the same and the y values are opposite. So those are the coordinates all the way around the unit circle, okay, for 45, 90 triangles, okay? Continuing on, we're going to go to our 30, 60, 90 case. Again, just like before, we don't want our hypotenuse to be 2. We actually want our hypotenuse to be 1. So what do? I'm going to divide everything by 2. All right. Now my radius is 1. Now I have my y values and my x values at each of those increments all the way around my circle. Okay. So I'm going to leave that triangle in the picture so you can see. But if I wanted to come up with the coordinates at 30 degrees, well, if you notice, my x value is root 3 over 2, and my y value is 1/2. So if I drop down to quadrant 4, I know the x values are going to be the same, and the y values are going to be opposite. If I go to that same reference angle over in quadrant 2, I know my x values are going to be opposite. My y values are the same. And then finally, quadrant 3, I know that both the x and y values should be opposites of each other. Okay? And the nice thing about this is if I take my coordinates at my 30-degree angle and I were to flip them up to the 60-degree, notice they should just be flipped. So we have 1/2, we're at 3/2. In quadrant 4, we still have 1/2, but our y values are opposite. Quadrant 3, both our x and y coordinates are opposite. Both the x coordinates opposite, the y value is the same in quadrant 2. So if you can see, a lot of your friends have probably told you before that you have to memorize all of this information in the unit circle, when in actuality, all you need to know is your special right triangles and the fact that your x value is always your cosine and your y value is always your sine. Then you're able to construct quadrant 1, and then you can use symmetry to find all the other quadrants. And I hopefully color coordinated this well enough for you. Okay? So the question is, how is that useful? Well, for us, as we continue on to these next problems, I'll try to leave that there for you. The nice thing about this, again, is it's a shortcut using those special right triangles. So if I'm looking for the sine value at 7π6, I'm thinking sine, remember, is y. So what's the y value at 7π/6? Well, your answer is -1/2. Okay? Not super useful in terms of everyday life, but in terms of our unit circle, these are going to be shortcuts for us. I don't need to type them in. I don't need to draw triangles for them. I don't need to know anything else besides the angle measure. Cosine of 135 degrees. So I'm thinking, remember, cosine's always tied to your x value. So I'm thinking, what's my x value at 135? So I go to 135 on the unit circle, and I wind up with -√2/2. Very last one, tangent values. All right, tangents we haven't really talked about to this point yet, but if you remember, tangents always opposite over adjacent. And if we look at our special right triangles up here and up here, if I do opposite over adjacent, my tangent value is always going to be that y value over the x value, or the opposite over adjacent side. So in the case of 7π/4, 7π/4 is right down there. So I'm going to take my y value, which is -√2/2, divided by the x value. If you notice, they're the exact same thing. So those are going to simplify to -1. Okay. Again, there's nothing to type in our calculator. We are just pulling these exact values directly from our unit circle. Okay. Normally, we'd have you do a unit circle quiz, 16 points, fill in all of the degrees and radians, fill in all the coordinates all the way around. You can retake it as many times as you want. Obviously, this quarter, we don't have that luxury. So know this as best you can, and please understand that you're going to need to know this moving forward. All right, so the unit circle, again, not super useful in everyday life, however, super important to your higher levels of math. The assignment's on the bottom of the board. Again, if you have any questions on the assignment or in general, utilize the discussion board online. Come to the live sessions as well. That might be something of use for you. Otherwise, best of luck on the assignment. There's going to be a review sheet due tomorrow, and then we're going to be using IXL on Monday for some quizzing. All right? If you have any questions, again, let me know. Otherwise, best of luck on your 12-3 assignment.